where the specialists are monitoring the various checkout parameters of their respective systems. We have another 3 minutes, 30 seconds to go for the launch.
Onboard computers in flight mode.
So minus 3 minutes, 15 seconds for the launch. The launch gun and the fueling complex.
Mark minus 3 minutes.
So mark minus 3 minutes. Two minutes, 37 seconds. Mr. Kunikrishnan, the director of Satish Dhawan Space Center, we're just waiting for the final phase of countdown. 2 minutes, 25 seconds to go for the launch now. As far as the overall mass of the vehicle at the liftoff is concerned, 320 tons. And the primary orbit that is designated for IRNSS 1E is 284 km perigee and 20,650 km apogee with an orbital inclination of 19.2 degrees.
Mark minus 2 minutes.
So we are just 2 minutes away from the vehicle liftoff. All experts at the Mission Control Center, Launch Control Center closely monitoring the vehicle parameters. So minus 1 minute, 48 seconds. So automatic launch sequence is indicating all the various health parameters that are being checked out by the onboard computers.
Mark minus 1 minute, 30 seconds.
1 minute, 28 seconds to go. So at T0 we will have the ignition of the S138 stage along with the ignition of the 4 solid strap-ons. And 25 seconds later we will have the ignition of the remaining 2 solid strap-ons. So minus 1 minute, 7 seconds.
All stations stand by for the time mark. Mark minus 1 minute and counting.
इस समय हम काउंटडाउन से ऑलमोस्ट 1 मिनट की दूरी पर.
Minus 55 seconds.
All subs armed.
Minus 50 seconds.
All sequences armed.
Minus 45 seconds.
So minus 45 seconds. Minus 40 seconds.
Minus 35 seconds.
Minus 35 seconds.
Roger.
So
Minus
another
25 seconds.
25 seconds.
PSLV opened.
Minus 20 seconds.
Minus 18 seconds.
15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, plus 1.
So first stage ignited.
Plus 3, plus 4, plus 5, plus 6, plus
So
7, plus 8.
First stage along with 4 solid strap-ons has been ignited. The liftoff is normal.
Plus 15 seconds.
Liftoff is normal.
Plus 20 seconds.
20 seconds into the flight.
Plus 25 seconds.
Vehicle is in a
Plus 30 seconds.
So as I mentioned to you, at 25 seconds into the flight,
Plus
we
35
have the
seconds.
ignition of the remaining 2 airline strap-ons. So now the vehicle with S139 and the 6 solid strap-ons are going through the intense and
Plus 45
phase of
seconds.
flight, roughly at an altitude of around 10
Plus 50
kilometers.
seconds.
So at 70 seconds into the flight, we will have the separation of the ground lead strap-ons, which were ignited
Plus 1 minute.
S138 stage. And at the 92 seconds, we will have the separation of the air lead strap-ons, which were ignited in 5 and 25 seconds into the air.
Ground lead strap-on separation.
just now got the confirmation that the ground lead strap-ons, 4 strap-ons have been successfully separated at 70 seconds. The vehicle is at an altitude of around nominally at 32.3 kilometers. 85 seconds into the flight.
P2 tracking SCPT1. Plus 1 minute 30 seconds.
At 92 seconds, we should hear, yes, airlift strap-on has been separated at 92 seconds.
First stage performance normal.
Altitude is 44 kilometers, and the vehicle has moved from the launch base at a distance of almost 65 kilometers. The vehicle velocity, as expected, during the first stage of flight, nearing the first stage separation is around 2 kilometers per second. The next event is at 110.
PS1 stage separated and
94
PS2
seconds.
engine started.
So we just heard the announcement. The first stage has been successfully separated, 111 seconds. And the second stage, ignition, has been initiated immediately after the separation of the first stage. And the vehicle has also entered into closed loop guidance algorithm.
Second stage performance normal.
So second stage performance has been indicated as normal. If you look at the burn time of the second stage, it burns for almost 145 to 150 seconds. And as per the nominal flight sequence, we can expect the separation of the second stage to happen at 262 seconds when the vehicle is at an altitude of around 134 kilometers with a velocity of almost 5.3 kilometers per second, which basically means the first two stages of the rocket would deliver almost 50% of the velocity which is required for the satellite to reach its designated orbit. So 174 seconds into the flight, altitude is 102 kilometers. During the second stage of flight, we have another important event called as the separation of the payload fairing or the heat shield, which primarily protects the spacecraft during the atmospheric phase and during the intense radiation that happens during the atmospheric phase. And once we are out of the atmosphere around 110 kilometers plus, the heat shield is separated so that we don't carry any dead weight beyond this particular event. So we just heard the announcement, heat shield has been successfully separated at 198 seconds. और जहाँ तक लॉन्च के टाइम का सवाल है, इस वक्त 213 सेकंड हम सेकंड स्टेज के फ्लाइट में और 30 सेकंड का टाइम बाकी और व्हीकल की ऊंचाई इस वक्त ऑलमोस्ट 123 किलोमीटर and if you look at the velocity, almost 4 kilometer velocity has been added. The nominal time at which the PS2 should separate is 262 seconds. It's around 25 seconds from now. And PSLV performance has been normal. If you look at the plots that were shown on your screen, is the plot of the altitude and the velocity. The flight that is going through the phase right now is exactly following the pre-flight predictions. So any time from now, we should hear the announcement. Yes, PS2 has been separated at 262 seconds. And the third stage also has been ignited. A very close match with the pre-flight predictions. So 275 seconds into the flight. Altitude 135 kilometers. And the vehicle has moved almost 650 kilometers from the Sri Harigoda. As you can see on your screen, all the flight events. Chairman ISRO, Shri Kiran Kumar.
Plus 5 minutes.
5 minutes into the flight, 300 seconds. A view of the altitude and the velocity profiling. What you are seeing on your screen, the bottom curve is the altitude profile. The red curve indicates the pre-flight predictions. And the green shown is the flight measured telemetry data. So very close match with the altitude, time versus altitude and time versus velocity. As per the nominal flight sequence, the third stage should burn out at 386 seconds.
Third stage performance normal.
And after the burnout, we almost have a post-burnout event of almost 200 seconds plus before the third stage gets separated and the ignition of the fourth stage happens. So we are into 345 seconds into the flight with an altitude of 138 kilometers. The velocity is 6.52, all looking nominal.
Plus 6 minutes.
So if you look at the velocity addition that happens during the entire phase of flight, As I was mentioning, during the first stage of flight, we have almost 25% of the velocity addition that has been provided to the vehicle. During the second stage flight, we have at the end of second stage flight, almost 56% of the total velocity has been imparted to the vehicle. Now the third stage, which ignites
Third
at
stage, burn out.
264 seconds after liftoff, this happens 1 second after the
Combined
early stage
posting has
separation.
started.
At the time the third stage separates, the vehicle is at an altitude of 186 kilometers, and the velocity of PSC separation is almost 7.7 kilometer per second. Now this mission being a 284 by 20,650, almost sub-GTO orbit, the velocity that the vehicle has to impart to the satellite is of the order of 9.6 kilometer per second. So we have almost a 7.34 kilometer per second velocity already imparted to the rocket. 417, 18 seconds into the flight. Probably at PS3 burnout, and then PS3 separation should happen at 605 seconds. So after the burnout of the third stage, there is a coasting time of, as I was mentioning, nearly 230 seconds before the fourth stage is ignited. This is primarily decided by the mission requirements to optimally meet the target condition.
Performance during combined posting is normal.
And PS3 has burnt out, and the vehicle is going through the combined coasting, which is the PS3 and PS4 stage together before it is separated. So coasting is basically the phase where the rocket motors are kept in the off condition. And इस वक्त समय 470 seconds और vehicle की ऊंचाई इस वक्त 160 किलोमीटर, and the vehicle velocity is 7.3. The final velocity that the satellite has to receive is around 9.6 kilometer per second. As I was mentioning, during the coasting phase of flight, the rocket motors are in off condition. At the end of the coast period, the fourth stage gets ignited at 616 seconds and burns nominal for almost 510 seconds. So nominal burn time of fourth stage is 510 seconds, which is going to take the satellite to the required elliptical orbit of 284 by 20,650 kilometer, where the velocity will be around 9.6. So once the target conditions are met, IRNSS satellite will get separated after nearly 37 seconds. So right now the time is 516 seconds with 7.3 kilometer velocity. And as you can see, during the coasting phase, there is a steep rise in the altitude. Even though the perigee is around 284, the final injection altitude is to the extent of almost 450 kilometers. So there is a continuous rise in altitude during the third and fourth stage when the coasting is going on.
Performance during combined posting is normal.
We just heard the announcement. The performance during the combined coasting is nominal. So we should expect the PS3 separation to happen in the next 50 seconds from now, followed by which we will have the ignition of the fourth stage 10 seconds after the third stage has been separated. So we are at 567 seconds. As you can see, because the rocket stage is completely off during this phase of flight, what you will see is there is a drop in the velocity because the vehicle is continuously climbing. The altitude, once the altitude increases, the velocity is going to drop down because there is no finite velocity addition that is taking off if the rocket motors are in the off condition. So once the PS3 stage is separated and PS4 stage gets ignited, you will see as the altitude is increasing, there will be increase in the velocity addition. So we expect something like 2.2 kilometer velocity to be imparted by the PS4 stage. So we just heard the announcement, PS3 has been separated as planned at 605 seconds. Maybe in the next 5 to 10 seconds we should hear, yes, PS4 engine also has been successfully ignited at 616 seconds. So we have view of the mission control center, the VVIP gallery. Just waiting for, yes, fourth stage has been performing nominally. So during this phase of flight, which is a duration of almost 500 seconds, the vehicle from the present altitude of 194 kilometers should reach something like 450 kilometers. And the velocity from the present 7.4 kilometer should take the satellite to a velocity of around 9.6. As you can see on your screen now, the velocity is slowly started to increase because the rocket motor has been ignited. 678 seconds, almost 200-kilometer altitude. As for the nominal timing that we have with us, the PS4 cutoff should happen at 1122 seconds when the vehicle is at an altitude of 450 kilometers, and 37 seconds later, after the cutoff of the fourth stage, the separation of IRNSS 1E satellite will be executed, which would be at 1159 seconds when the vehicle is at altitude of almost 502 kilometers. So right now we are 712 seconds into the flight, and the satellite with the upper stages almost reach a distance of 3,600 kilometers, which is called as the downrange. And altitude is 208 kilometers. Just a quick details on the IRNSS 1E satellite. IRNSS 1E satellite had a liftoff mass of around 1425 kilograms. And this configuration of IRNSS 1E is similar to that of IRNSS 1A, 1B, 1C, and 1D. The two solar arrays of IRNSS 1E, consisting of ultra triple junction solar cells, generate almost 1660 watts of electrical power. And with regard to the attitude or orbit control system, also called as the AOCS of IRNSS 1E, maintains satellite orientation with the help of reaction wheels, magnetic torquers, and thrusters. So four-stage performance is normal. And with regard to the propulsion system of IRNSS 1E, it has a liquid apogee motor, which is primarily used for raising the altitude from its present altitude of from the initial orbit of 284 by 20,000 into the final designated orbit of 36,000 kilometers. And there are also thrusters for maintaining the attitude control. So after injection into the intermediate transfer orbit, these two solar panels of IRNSS 1E will automatically get deployed in quick succession. And the master control facility, MCF, at Hassan will take control of the satellite and perform the initial orbit racing maneuvers, consisting of one maneuver at perigee. So the maneuver strategy from the present position of 284 by 20,650 kilometer will take the satellite to a final orbit of 36,000. So there will be a maneuver performed at the perigee, which is the nearest point of Earth, and there will be three maneuvers that will be performed at apogee for placing the satellite in the final designated orbit. And in terms of the location at which the satellite will be positioned, it will be at a 111.75 degrees location, and the initial inclination of the orbit will be to the extent of 28 degrees with respect to the equator. So 840 seconds, velocity is around 8 kilometers, PS4 performance is absolutely nominal, altitude 240 kilometers.